Hello students, welcome back to my YouTube channel Rouser's class. In the previous class, I have explained about you basic concepts of coordination compound, that is double salt and coordination compound. If you have not watched the video, just go to the playlist and you just see that one. And today I'm going to explain you first theory of coordination compounds, that is Werners theory. This is the first theory that explained about the bonding in coordination compound. So it explained about bonding. So which type of bonds are there and how they are formed and all. It explained about bonding in coordination compounds. It's a very old theory, I think 120 years before theory. So, but yet it is very useful theory. What Alfred Werner, what he did is he took four compounds, CO, cobalt trichloride. All are cobalt trichloride, but different ammonia molecules. 6NH3 molecule, then cobalt trichloride with a 5NH3 molecule. Similarly, cobalt trichloride with a 4NH3 molecule and cobalt trichloride with a 3NH3 molecule. He took four different compounds and they have different color also. Although they are cobalt trichloride, but because of ammonia the color changes. The first one is yellow color, the next one it is a purple color, next violet color, and the next one it is blue color, right? So these compounds, what he did is he wanted to check the presence of chloride ion. What is the test to detect chloride ion? Test for chloride ion is take the compound, whatever the compound it is, and add silver nitrate, AgNO3. So you will get white precipitate of AgCl. White precipitate of AgCl is formed if the compound is having Cl minus. This is the test for detection of chloride ion. What is that? Take the compound having chloride ion and react it with AgNO3. So you will get white precipitate of AgCl. So here also these all things are having chloride ion. So he reacted with AgNO3. He reacted each compound with AgNO3 and he calculated the number of moles of AgCl formed. Number of moles of AgCl formed on treating with AgNO3. He took this compound, reacted with AgNO3. So how obviously there are 3 chloride ions, so which means 3 moles of AgCl is formed. It was a very obvious thing. Now he took the second compound, again reacted with AgNO3, but despite of having 3 chloride ions, he got only 2 moles of AgCl. He was surprised. There are 3 chloride ions, but yet I got only 2 moles of AgCl on adding AgNO3. Why? It was a question. And here 3 chloride ions are there. On adding AgNO3, he got only 1 mole of AgCl. Again surprise. And here there are 3 chloride ions and here 0 moles of precipitate. There is no precipitate formed on adding AgNO3. Then he was surprised why it has happened. So then he concluded one thing, that here there is no precipitate of AgCl, which means the chloride ions are non-ionizable. They must be non-ionizable, means they are not coming out, which means the chloride ions all are presenting inside the bracket. He thought all the chloride ions must be presenting inside the bracket, and that's why there is no ionizable chloride ion. That's why on reacting with AgNO3 I am not getting AgCl precipitate. Here 1 mole of AgCl is formed, which means out of the 3 chloride ions, only one chloride ion is ionizable, which means one chloride ion present outside the bracket, remaining everything inside the bracket, which means the compound must be like this: CONH3 4 times, all ammonia 4 molecules, 2 chlorine, and 1 chlorine is presenting outside the bracket, that is called as ionizable chloride ion. That ion react with AgNO3 to, that's why we got only 1 mole of AgCl. So this is ionizable, and the bracket inside they are non-ionizable. Now you tell me what happens here. 2 moles of AgCl is formed, which means out of the 3 chloride ions, 2 chloride ions are ionizable and 1 chloride ion is non-ionizable. So which means 1 CONH3 5 times 1 chloride ion is present inside the bracket, and the remaining 2 chloride ions are presenting outside the bracket. That's why the 2 chloride ions are ionizable, and that's why 2 moles of AgCl is formed. And here 3 moles of AgCl, which means all the 3 chloride ions are ionizable, which means they all present outside the bracket. So which you can say CONH3 6 times and Cl3. So these must be the formulas of the compound. This is what Werner has said. Now, so I repeat, the bracket which present outside the bracket, they are ionizable and they give their test, and which present inside the bracket, they are non-ionizable. Okay, understood this one? Yes. So now based on this experiment, this is the experiment he has done. Based on this experiment, let us make some postulates. So take example of some compounds. This one, I'll take this one. Example, CONH3 6 times Cl3. This is the example for a coordination compound. Or you can have many example, K4FeCN6. It is also called coordination compound. So based on this, he has given some postulates. This is a central metal. This is cobalt is a central metal and iron is a central metal. So he said in coordination compounds, each metal has 2 valencies, not 1 valency, 2 valencies, namely primary valency, you call them as primary valency, and second one is secondary valency. Primary valency and secondary valency. Yes, what is primary valency and what is secondary valency? Let us see. Primary valency. What primary valency means? Which present outside the bracket. 3 chloride ions are here, 4 potassium ions are there. That's called as primary valency. So primary valencies mainly locate outside the bracket. That is a point number 1. Outside the bracket. Now they are ionizable or non-ionizable, you tell me. They get separated or not? Yes, they are ionizable. Primary valencies are ionizable, so they gives their corresponding test. Whatever the test, chloride ion test or potassium ion test, whatever the test, they give the corresponding ion test. Next, they form ionic bond with metal. They form ionic bond or electrovalent bond with metal. So here chloride ion form ionic bond with cobalt. Here potassium ion form ionic bond with iron. And they are satisfied by, primary valencies are satisfied by either positive ion or negative ion or neutral molecule. So positive ion can be primary valency can be either positive ion or negative ion or neutral ion. This is all about primary valencies. Now whatever present inside the bracket, that is called as secondary valency. Let us talk about that secondary valency now. Now secondary valency, yes, where do they present? Secondary valencies, they locate inside the bracket, yes, they are ionizable or non-ionizable, whichever present inside, they are non-ionizable, yes. They don't give test of corresponding ion because they are not getting ionized. That's why obviously they don't give the test of corresponding ions. And yes, they form primary valencies form ionic bond, but they form coordinate bond with metal. I'll show you example also. Like I have taken CONH3 6 times Cl3, correct? This example we have taken initially. So here this one actually present like this: CO, 6 ammonia molecules. 6 ammonia molecules will present like this. These all are coordinate bond, not simple covalent bond. They are coordinate bond ammonia at 6 places. The structure is called octahedral structure. It is octahedral structure. And yes, the charge on this one here 3 plus and outside 3 Cl minus. This is the original structure. So here chloride ion is forming ionic bond, plus minus ionic bond, and it is a coordinate bond. So I said secondary valencies means these all are secondary valencies. The secondary valencies form which bond with metal? That is a coordinate bond with metal. And secondary valencies are satisfied by, either negative ion or neutral molecule, but not positive ion. Positive ion will not come. It is either negative ion or neutral molecule. Why not positive ion? That we will see further. At the end we will come to know about it. This is about a secondary valency. Secondary valencies means which present inside the bracket, and they are non-ionizable. They all are non-ionizable. That's why they do not give the test of corresponding ions. They form coordinate bond with metal, and they are satisfied by either negative ion or neutral molecule, but not positive ions. It is all about Werners theory points. And one more point he said, the number of secondary valencies, which present inside secondary valencies is called as coordination number. Why he called it as a coordination number? Because they form coordinate bond. So you can see these all are forming coordinate bond. That's why that number is called as coordination number. Yes, let us take example this one. So this chart we have begun with initially. So here you tell me primary valency and secondary valency here. Primary valency and secondary valency. Primary valency means which present outside the bracket, which is a 3 valencies, here 2 valencies, and here 1 valency, and here 0. Correct. Secondary valency, which means inside the bracket there are 6 ammonia molecule, 5 ammonia and 1 chloride, which means 6, 4 ammonia and 2 chloride, which means 6, and 3 plus 3, which is 6. This secondary valency is only called as coordination number. So coordination number can be, again you can say 6, 6 and 6. This is the table related to Werners theory. So I can add one more point here, that is the coordination number of any metal is fixed, and it determines the geometry of molecule. Determines the geometry means what? Structure of molecule. So if coordination number is 6, like we have seen here, coordination number is 6, then the structure is octahedral. If the coordination number is 5, the structure is going to be trigonal bipyramidal. If coordination number is 4, then it is either structure is square planar or tetrahedral. These are the most common ones, and this is all about Werners theory. So in state board, generally they ask 5 marks question about postulates. You can write all these postulates, and in normal examinations in CBSE they ask 1 mark questions, and in JW also questions are there. Now next I will explain you what are the questions asked in JW, right? Yes students, now we studied Werners theory. Now some questions based on Werners theory are here. So this is the question asked in AI PMT 2015, which means a NEET exam. Right now we call it as a NEET exam, and olden days it is a AI PMT exam. You see what is asked. Cobalt chloride, cobalt 3 chloride, which is the oxidation number, forms several octahedral complex. Octahedral complex means what? The coordination number should be 6. Coordination number should be 6. With ammonia, which of the following will not give test for chloride ion? Will not give test for chloride ion. Right. So now, yes, which one do you think? Yes, first you write this in a complex form. So here octahedral it is said, so coordination number should be 6. So this compound can be written as CONH3 5 times. Out of 3 chlorine, 1 chlorine will present inside the bracket and the remaining 2 chlorine present outside. So that inside coordination number will be 6. Here how can we write CONH3? How many ammonia are here? 3 ammonia, and 3 chlorine will present inside the bracket, so that coordination number will be 6. And here 4 ammonia are there, so 4 ammonia will present inside the bracket, and 2 chloride ions will present inside, and 1 chloride ion will present outside. And this one 6 ammonia are given, so which means 6 ammonia present inside the bracket, and the remaining 3 chloride ions will present outside the bracket. Right. Now which one will not give test of chloride ion? Test of chloride ion will not be given by which one? So here 2 chloride ions present outside, so it will give test. 3 chloride ions outside the bracket, 1 chloride ion, but here there is no chloride ion outside the bracket, so this compound will not give the test of chloride ion. So that's the answer. It's a 4 marks question. Understood it? Right? So if you understand my classes, please hit on the like button, so I get inspiration and I do make more and more videos for you people. Yes, now let us see this question. This is a very interesting question. This is asked in Kerala. It's a Kerala PET 2011. Kerala PET 2011. Yes, what is this question? When 0.01 mole of cobalt complex is treated with excess AgNO3 solution, it is giving 4.305 gram of silver chloride. Silver chloride formula, it is AgCl. So the formula of the complex is, yes. So if you want to give a try, pause the video and give a try and put your answer in the comment box. Right. Meanwhile, I will explain here. See, what is said in this question, 0.01 mole of compound is giving 4.305 gram of silver chloride. Correct? So let us convert this into moles. Number of moles, how can we do? Number of moles is equal to given mass upon molar mass. 4.305 upon molar mass of AgCl. Ag mass is 108 and Cl mass is 35. So it means 143.5. Yes, divide it. So what you will get? You can write like this: 430.5 into 10 power minus 2 divided by 143.5. So approximately 3 times, which means 0.03 moles. Right. So which means 0.01 mole of compound is giving 0.03 mole of AgCl. So if you can take out the ratio, one compound gives 3 AgCl molecules. 3 AgCl molecules of precipitate. So now in which case 3 AgCl is formed, that you have to identify. It's easy. Here there is no chlorine outside, so it will give 0 moles of AgCl. Here 2 chlorides are outside, so you will get 2 moles of AgCl. Here there are 3 chlorides, I will get 3 moles of AgCl. And here there is no chloride, so which means 0 moles of AgCl. And here it is 1 mole of AgCl. So here one compound is giving 3 molecules of AgCl, so therefore answer is C. Understand? It's a very easy concept, but very important concept as well. Now this question, let us see this question number 3. Question number 3. A solution containing 0.319 gram of chromium chloride complex, 0.319 gram of chromium complex was passed through a cation exchange resin, and acid coming out of cation exchange resin required 28.5 ml of 0.125 molar NaOH. Determine the formula of the complex. This was asked in AIMS 2014. So very tough question. So the complex compound, first understand that what is given. So let me say that. Question number 3. 0.319 gram of chromium complex, that is a CrCl3.6H2O, is passed through cation exchange resin. So there you will get chloride ions. Of course you will get Cl minus ions get separated, and that Cl minus ions are treated with which one? 28.5 ml of 0.125 molar NaOH. So determine the formula of the compound. Yes, any idea how to solve this question? Whenever this kind of questions are there, first convert this data into number of moles. So here molar mass is also given, that's a very good thing. So 266.5. So convert this one also moles and this one also moles. Okay, so how to convert moles? Number of moles is equal to given mass upon molar mass, 0.319 divided by molar mass of the complex is 266.5. Yes, simplify it and tell me what will come. What is the value here? Approximately I can say 319 into 10 power minus 3 divided by 266 approximately. I think yes, it is a one time. So 1 into 10 power minus 3, it is 0.001 mole. Okay, this is the compound I am taking. Now here, how many moles of NaOH needed? So this I have to convert into moles. How to convert this one into moles? Tell me how to convert. Yes, we know the formula. Molarity is equal to number of moles into 1000 by volume. Now number of moles is equal to molarity into volume divided by 1000. So now that formula I'm using. So convert that. Number of moles is equal to molarity is how much? 0.125 into volume. Volume is 28.5 divided by 1000. Now I have to solve without calculator. Yes, this I can write as 1 by 8 into 28.5 divided by 1000. So 8 ones are 8, 3s are 24. 24 4 carry 3.5, which means 0.0035 moles of NaOH is needed, which means 0.0035 mole of Cl minus is getting separate, right? So now what is understood here, that is 0.001 mole of compound is giving 0.003 moles of chloride ion, which means one compound is giving 3 moles of chloride ion. So now we have to check the options. Check the options. Yes, here how many chloride ions will get? 3 moles of chloride ions we will get. Here only 2 moles of chloride ion because 2 chloride ions present outside. Here only 1 mole of chloride ion, which because 1 chlorine is outside. Here 0 moles. So here answer is what? A. So the answer is A. So in this way we can easily think about it. So clear here. So first, see, we should not get nervous because it is a AIMS question. So obviously it is a tough one. First, 0.319 gram of compound was passed through a cation exchange resin, and the acid coming out of the cation exchange resin required 28.5 ml of 0.125 molar NaOH. So what I have written is 0.319 gram of compound is giving Cl minus and get separate after passing cation exchange resin, which requires 28.5 ml of 0.125 molar NaOH. This is the given data. Now we should not get nervous in this kind of questions. Convert the data into number of moles. Here I converted the whole data into number of moles. How? Number of moles is equal to given mass upon molar mass. And here number of moles, molarity is equal to number of moles into 1000 by volume. So number of moles is equal to molarity into volume by 1000. So I got number of moles. So which means 0.001 mole of compound is giving 0.003 moles of Cl minus. So which means one compound is giving 3 moles of Cl minus. So the answer I have got is A option. Right? Understood it? So okay. So keep doing it. Now next question. Now next question. Yes, this is again very easy question. Yes, this is asked in Kerala exam, Kerala PET 2008. Yes, see, these all are based on Werner theory only. The question is, two isomers of X and Y with a formula, both have same formula, Crs H2O5 times Cl Br2, were taken for experiment in the depression freezing point. That is okay, different experiment which you will learn in solution chapter. That's not needed now. It was found that the 1 mole of X, you see this is the data, 1 mole of X give depression and freezing point correspond to 2 mole of particles, and 1 mole of Y gave depression in point freezing point correspond to 3 moles of particles, which means 1 mole of X is giving 2 moles of particles and 1 mole of Y is giving 3 moles of particles. So what are the structure of X and Y? You see this one, X, this is a X and Y separation. So here how many moles you are getting? One big molecule and one bromide ion, which means here 2 moles, and here plus minus. Here how many moles? One big ion and one chloride ion. Water will not be considered. So here I am getting 2 moles. So this is the X, this is the Y. So X should give 2 mole and Y should give 3 mole. Here it is giving 2 mole, it is also giving 2 moles of ions. Here how many moles of ions are formed? You tell me. How many moles of ions are formed? If I want, I'll write in detailed also, so don't worry about it. Question number 4. Question number 4, B option. B option, you see how it will dissociate CrH2O 5 times Cl. Okay, here the 2 bromide ion, that's why 2 plus charge will come and 2 Br minus will get separate. So totally how many number of ions are here? 3 moles of ions. And the next one, this one, yes, there is no charge here, so only the complex will remain as it is, CrH2O thrice ClBr2. So which means here 3 moles of ions are getting formed and here only 1 mole of compound is getting formed. Like this, you see C option, how it will get separated? C option, CrH2O 5 times Br. Okay, so here it is a 2 plus charge and Br minus ion as well as Cl minus ion. Totally how many moles of ions are getting formed? 3 moles. And this one, CrH2O 4 times Cl2. Cl2 must be there. Yes. Here Br minus is going outside, so what charge will come? Plus charge, and only 1 Br minus, so totally 2 moles. So the question is said X should give 2 mole and Y should give 3 moles. You see the E option. E option, what is there? It is a plus charge, it is a minus charge, which means 1 ion and this is another ion, so which means 2 moles of ions are formed. And here it is a 2 plus charge and 2 bromide ions, which means 3 moles of ions are getting formed. Therefore the right answer is E. X should give 2 mole, Y should give 3 mole. So answer is E. Understood it? Right. Now the next question. Now question number 5. You see question number 5. A solution containing 2.675 gram of complex with molar mass 267.5 is passed through a cation exchanger. The chloride ions obtained the solution were treated with excess of AgNO3 to give 4.78 gram of AgCl. The formula of the complex is, so here it is a AIEEE question asked in 2010 for 8 marks. You know, that time there were 8 marks questions, so this was asked for 8 marks. Very easy question. So convert this. Let us solve this question. Question number 5. Question number 5. First write the given data. Given data, what is that? 2.675 gram of compound is giving chloride ions are passed through the cation exchanger and something 4.78 grams of AgCl. So you know how to solve this question. Convert this into number of moles. Number of moles is equal to given mass 2.675 gram upon molar mass. Molar mass it is given here, you see it is a 267.5, which is equal to 0.01, right? Yes, 0.01 mole. Now this one, convert this. Given mass is a 4.78 gram. Molar mass is given here 143.5. Let us do one thing. It is a 478 into 10 power minus 2 divided by 143.5. It is approximately 3 times. So which means 0.03 mole. Which means it is clear now. 0.01 mole of compound. 0.01 mole of compound. It is giving 0.03 mole of AgCl, which means one compound should give 3 chloride ions. So in which option that facility is there, you just see. So here 2 chloride ions will be separated, here 3 chloride ions will be separated, here only 1 chloride ion, and here no chloride ion. So therefore answer is B. So this is about Werners theory and its questions. I hope I made you to understand very well. I'm trying my best to give best possible knowledge. Please do subscribe my channel and share with your friends. Thank you guys and take care of yourself.